Hi everyone. In this video, I'm going to explain one of the fundamental concept of any operating system is process synchronization. So before going to technically what do you mean by process synchronization, let us discuss what is process, what is synchronization in general. So already we know that in my previous video, I explained what do you mean by process. What is process? A process is nothing but a running program or a program under execution. It's nothing but a process that we know. In simple words, program under execution are also called as running program is a process. That's not, it is a running program. So the program is running means, so any process should belong to either it should be cooperative process or it should be an independent process. That means we broadly categorize our process into either independent process or it should be a cooperative process. Any process, it should be either belongs to cooperative process or independent process. As the name itself, this indicates the independent process. Means this process is not depending on any of the process. That means it will do completed execution depending on this only. It is not depending on other. It is not depending on any other process. Means there is no communication between other process. See, when there is no communication means, so when the two processes need to communicate, whenever the two processes is having something to share among these two, then only they need to communicate. When there is nothing is there to share, then no need to communicate. So these process, independent process are the processes which never communicate with others. Never communicate means it shares the data. That means no sharing of any data. No sharing of anything. Okay, no sharing. So since it is independent, since it is not sharing, since it is not communicating, so this process never get affected by other processes, or this process is not going to affect other processes. What do you mean by this? See, whatever we are using today's, we are multi-programming environment, right? That means we are executing multiple programs at the same time. That's the word, same time. Simultaneously, we are executing multiple processes. That means multiple processes are executing. If the two or more processes are communicating with each other, that means if they are sharing, there may be a possibility, there may be a possibility of one process is affecting other process, or one process may get affected by other processes. Now, since these independent processes not communicating, not sharing anything, so this process never get affected by others, or this is not going to affect others. Okay, so now this no concept of this synchronization only. Okay, now we come to the cooperative process. Now, cooperative processes are the processes which communicate with other processes. That means communicates. Why we need to communicate? Whenever we have something to share, so then only two processes has to communicate. Okay, so since these processes are communicating, so they share something. Okay, now what and all the possibility of two processes or two threads can share? So this may be it what was okay. We'll call the share means it may be some data or it may be some resources. Okay, now what and all may be the data? So the data may be a simple one variable or some database or some table. Okay, or this may be some other data. Okay, or it may be the code also. Okay, so for example, if you written a global variable in a program, global variable, and all the function presents in that particular program is sharing that global variable. Okay, and database, but maybe also be shared. Some table, again, database table almost similar. A code. Sometimes I have written some code, and that code, the same code can be used by multiple processes at the same time. For example, some of the mathematical functions or some standard input output functions, whatever we use. Okay, so that the code can be reused. That means can be shared among multiple processes. Okay, so this one. Resources means a file can be shared among the multiple processes. A particular one file is there. That file will be used by all the programs at the same time. For example, we are including so many header files. Okay, or it may share some CPU cycles. That means, see, we know that we are working in an environment called multi-programming environment. Multi-programming environment means we are able to execute multiple programs at the same time. How it is possible? But in our system we are having only one processor, only one CPU we are having, only one processor, uniprocessor systems. If in one uniprocessor systems, if we are, whether in our uniprocessor system we are executing one at a time, no, or multiple. But one processor, how it executes multiple, so it gives it maybe a time sharing systems. That means it will allocate 10 microseconds or 10 milliseconds something to each and every process. Because we know that our CPU can execute millions of instructions per second. Millions of instructions per second means, so millions means 10 lakhs of instructions. So for example, assume each process will get some, for example, some 10 microseconds. So assume there are four processors. Assume there are four processors, P1, P2, P3, P4. They are in the ready queue. Assume they came in this order. Now, first 10 microseconds is going to P1. After that, next 10 microseconds will go to the P2. Then the same CPU will be given to the P3 for 10 microseconds, like this. So that is what some CPU cycles, that means CPU cycle will be shared for 10 microseconds. First process, next for another process 10 microseconds. Like that, this CPU is also shared among our processors. And other than that, we have some input devices. The input device also shared among the processors. Similarly, output device. So between the two processes or two or more processes, a data can be shared or a resources can be shared. Okay, that means cooperative processes are the processes which are communicating each other in order to share the data or the resources. That's what the summary. Now, since these cooperative processes are sharing something between those, so there may be a chance of one is affecting other, or that one process which is sharing may get affected by the others. That is the problem. So now, since there is a problem only when we're communicating, we are talking only about cooperative processes in this entire topic of process synchronization. We are not talking about independent process. Okay, so since there is something is sharing, there is a problem. So what is the problem? See, whenever two or more processes are using the same shared thing, so then all those processes which are sharing the one thing, they should communicate with each other. They should coordinate with each other, saying that I am doing so and so, you please wait. After I did, then you people use. Like that, some coordination should be there. If everybody comes to use the shared data at the same time, then only it leads to some inconsistency of data. Okay, so that is the problem of the process synchronization. We know what is process now. Now synchronization means coordination. That's it, coordination. That means there should be some coordination between the two or more cooperative processes which are sharing the same data or same resources. Okay, if there is no coordination, then it leads to inconsistency of data. Okay, there is no fair execution. Okay, so to have fair execution and to have the data consistency, every operating system has to make some process synchronization methods. Okay, so let us see how this data become inconsistency if there is no proper coordination between the two processes. Okay, simple example. Assume two friends are there. Okay, assume two friends. They are what now I'm talking only about what cooperative systems. So assume two friends are maintaining one joint account. You know, people joint account means Assume they are maintaining joint account. Assume in the balance, initial balance, assume right now some 10,000 balance is there. 10,000 rupees balance is there. Now, assume two friends are there. Say, let us say process P1 and process P2. Both are using this joint account. Both are having the taxes. Okay, that means now this is shared. This variable is shared among these two processes. Okay, fine. Now, initially these two processes are good. There is a good relationship between these two. Whenever they are doing any transaction like our deposit or withdrawal, they are each informing one another. There is no problem. Assume after some days or some years, their relationship is not good. Assume now they both want to take this amount. Assume the balance is 10,000. Both want to take this one. So one person open the Google Pay, another person uses some Paytm or something else. Now both try to withdraw. Now this person will try to withdraw, say for example, 9,000 will withdraw. At the same time, assume this person also wants to withdraw 9,000. So is it possible both the process get 9,000? No way. If it does, it will lead to minus 8,000 balance. This is not possible in practical. That means this is data inconsistency. That means the problem is both are trying to withdraw at the same time. But it is not possible at the time. This is the problem. So one more time, one more example. Assume we have some variable, say a global variable, for example, x is equal to 10. X is equal to 10. Assume this is the global variable and there are two threads, that's two functions. We are doing the program is a global variable. Assume one process or one thread P1, another P2. Now both are using this variable at the same time. Assume one wants to increment it by 5, that means x plus 5, and another wants to do x minus 5. Now, if this person will do what happens, this will result to what? This value becomes 15 and this value becomes 10. Now, which is correct? Since both are did at the same time, so we don't know which will correct, which is correct. So this is the problem of data inconsistency. So one more example. Assume people want to book some movie ticket in the Book My Show. In the Book My Show, assume two persons are checking a particular corner seat. Okay, for example, C1 seat. That C1 seat is available, checked. No, it's available. See, that interface is same thing. Interface, okay, front end is visible to everyone. Now, but booking will be done at the background. Booking done will be background. So now the user interface and the background, these two processes has to communicate. See, if these two are not communicating properly, this is the problem, inconsistency. So now assume two persons are checking, both are seeing that this seat is available. Now both will try to what? Book the seat. Now, if both the time, so this seat can be allocated to two persons at the same time? No way. It has to be allocated to any one person. But it does not allow for two processes to book at the same time. Okay, so that's the problem. Okay, see, whenever one process is booking, now this user interface has to communicate with the person who's handling the database. So he has to inform that so and so person came first, he is booking. So you don't allow other process to book this seat. So this is the communication, this is the coordination. That means there should be some coordination between the two processes. Then only it will give consistent data. Otherwise it leads to like inconsistency of data like this. This is the problem of process synchronization. And why this data inconsistency become problem of process synchronization is what? Data inconsistency. Why this data is inconsistent? Again I'm telling, because here two or more processes are in the race to access that shared data. Let me see, both are in the race. I want to get first, like that both are in race to get this. Both are race in order to change the data. Both the processes are trying to book the seat. So that means when two or more processes are entered into the shared region at the same time, then it leads to what? Data inconsistency. Okay, that is the problem. So the condition where two or more processes enter into the shared region, then that condition we call it as race condition. Race condition. Okay, so this is the problem of race condition. So the race condition results in what? Data inconsistency. So it is the responsibility of every operating system, whichever the operating system, that operating system has to make sure that there should be this race condition should be avoided so that data should not become inconsistent. So data should be always consistent and there will be fair execution of all the processes, okay, one after the another instead of simultaneously. Okay, that is the problem. See, again, the problem here, everybody wants to access at the same time. If we allow one after the another, then there is no problem. Okay, so like in ATM machines. So here in the ATM machines, there the people will that allow multiple peoples to enter into the ATM machine and get withdraw at the same time. No. Okay, only one person is allowed into the ATM, and that one person has to use that ATM machine for his transaction. After that person completes, then only the next person. Similarly, when one person is booking this one, so we should not allow another one. After completing this person, then only we need to allot another person to book the seat other than this, because it's already booked by this process. So we should not allow. But what is the problem if you allow one by one? So it is not possible to achieve multiple programs at the same time. But today we are using what? We want to execute multiple activities at the same time. If you are allowing that one, so there is no concept of multi-programming. So if you want multi-programming, so every operating system has to ensure that there should be some proper synchronization, proper coordination, proper communication between the two processes or multiple processes. So this is what the process synchronization. So hope you people understood what do you mean by process, what do you mean by synchronization, what are two different types of processes, how cooperative processes works, and what do you mean by race condition, how this race condition leads to data inconsistency. Okay, so hope you people are understood. If you have any questions, please write in the comments. Thank you. Thanks for watching.